All right, we can still do multiple derivatives. It doesn't matter if it is trig or not. It's still a second derivative because it's a process, right? It's that process. So when you find a second derivative, you're taking the first derivative, then the derivative of that. Exactly. You guys know this stuff. So I'm going to have y is equal to cosecant x, and I want to find the second derivative. So what's the first derivative? Y prime is negative cosecant cotangent. Yep. Learn it and love it, right? Learn it and love it. Now what? Yep. I'm multiplying again. So here's where we actually use the product rule. I told you it was coming, so practicing that process is helpful now to put it into play. I'm going to keep this negative sign up here with this cosecant, just so that I can keep track of it. So the derivative of the first, so it is this negative of negative, the derivative of cosecant is cosecant cotangent, times the second, plus the first, which is negative cosecant, times the derivative of the second, which is that negative cosecant squared. So this negative times a negative over here is a positive. Now, let's put these together and clean this up a little bit. Let me change back to blue. So I have a double cotangent, so we'll write that as cosecant x, cotangent squared x. Over here I have 3 cosecants. So this is cosecant cubed that you have. You could factor out a cosecant if you want, or just leave it. It doesn't really matter. Cosecant, if you wanted to factor that out, you could have cotangent squared plus cosecant squared. I mean, honestly, for this one, it doesn't make one big of a difference one way or the other. But the moral of the story is, even if you have a second derivative, even if you have trig, it's still the same process, right? We're using everything together. As soon as you learn a process, we're implementing it. Good. It's just like breathing. Taking a derivative should be just like breathing. Okay, last example. I'm taking it out of the book, 3.5.30. Y is equal to the sine of x over 1 plus cosine x. And I have to find the derivative, of course. dy dx. That doesn't look like a d, so let's fix that, shall we? All right, so what do we get to do here? Yeah, we do. Quotient rule, right? So y prime here, derivative of the top. So the derivative of sine is cosine. We're getting it. Times the bottom minus the top just by itself times the derivative of the bottom. So the derivative of 1 is a constant, but the derivative of cosine is negative sine, right? Negative. So plus sine. I'm going to get used to writing things like that. All over the denominator squared. Okay, now clean this up a little bit. Y prime is equal to the cosine of x plus cosine squared plus sine squared. Ooh, that looks familiar, doesn't it? We just talked about this. There's my Pythagorean identity. That's a 1. Ah, that's cool. Look how nice this cleans up. Cosine of x plus 1 over 1 plus the cosine of x squared. What else do you see can happen? Sweet, right? One of these takes out one of those. Yes. And y prime is 1 over 1 plus the cosine of x. Oh, man, that's awesome. That's awesome. Good, see? Learn those. Love those trig derivatives. They're so handy. Knowing those is going to make a huge impact for you. Okay, great job, guys.